Let's begin to discuss about types of electrochemical cells. Types of electrochemical cells. Actually, there are two types of electrochemical cells, which are your primary cells and your secondary cells. Now, the primary cells, most times, is usually called the use and throw away batteries. Yes, while your secondary cells are called the rechargeable batteries. So, what's the major difference between the two of them? Well, for your primary cell, you have that your primary cell, the chemical reaction in them that helps us to produce electrical energy are actually irreversible. That means at the end of that reaction, when you have used the electrical energy generated, we can't use them again. We have to throw them away. Hence, they are called the use and throw away batteries. For the secondary cells, that are also called the rechargeable batteries, the chemical equation in them or the chemical reaction in them that generates electric current are actually reversible. That means you don't throw them away after the battery is now weak per se. That's when you have used up all the energy in them. You can actually reverse that process and generate more energy. Examples of your primary cells are actually called your Daniell cells and your Leclanche cell. This is them. Example of your rechargeable cells or your secondary cells is your lead acid accumulator that is used in your car battery. In the video you are going to watch, you are going to learn how these types of cells, primary and secondary cells, the mechanism behind them. You're going to learn the redox reaction, why it is that they are irreversible and they can no longer be used after we have expended all the energy in them, electrical energy. And you also learn about the secondary cells, why the chemical process that happen in them. I'm going to see you at the end of the video where we are going to do a review and a summary of all you would have learned.
Hello guys, in this video we are going to discuss some applications on galvanic cells. A voltaic cell can be primary or secondary. In this video we are going to discuss the primary cells, and in the next videos we will discuss the secondary types. Primary cells are not rechargeable and are discarded after they run down when all the chemicals are used up. In other words, no more chemical potential energy available, or the chemicals in the battery can react to produce electrical energy. Here I got the illustration of what happens to the primary cell. The anode loses electrons to the cathode and both connected by a wire. Here the cell generating electrical current, but when the battery is run out of reactants and almost they all turn it into products, the cell stops working and it can't be recharged again. So here is an example on primary cell, which is dry cell. Dry cell battery is a voltage producing battery containing the electrolyte chemical in the form of a thick paste. It produces voltages of about 1.5 volts. In this diagram, which represents the parts of a dry cell battery, the zinc casing provides enclosing to the electrolyte and the cathode as a whole. Ammonium chloride is the electrolyte used in this type of battery. Just ahead of the electrolyte lies a manganese dioxide, separated from the electrolyte by a separator. At the center of the cell battery lies a carbon rod, which is the cathode, and zinc casing is considered as the anode. So let's understand how it works. Every portion of the battery device has chemical reactions occurring within. While a reduction reaction occurs at the carbon electrode, oxidation proceeds at the zinc casing, which is the anode. The chemical reactions that define the entire energy process are as follows. At the anode, zinc loses 2 electrons and is converted into zinc 2+ ion. The ammonium ion from ammonium chloride reacts with the 2 electrons to produce ammonia and hydrogen gas. The manganese dioxide near the cathode reacts with hydrogen gas liberated to form manganese 3 oxide and water. Combining equation 1 and 2, we get the following equation. And combining all the above equations, we get. Due to these reactions, chemical energy gets converted into electrical energy. This energy then flows from the battery to the connected device through the outer circuit. So guys, here is a total recap of what we've learned today. Primary cells are used once and can't be recharged again. We will take a look at the nickel-cadmium cell and lead-acid battery. Secondary cells are galvanic cells that must be recharged before they can be used. They also can be recharged many times. In the charging process, the spontaneous feasible reaction that produces electrical energy is reversed. In other words, the charging process needs outside source EMF to occur. Here is a simple animation shows a typical secondary cell. During the discharging process, the electrons flow from the anode to the cathode, where the anode is the negative electrode and the cathode is the positive electrode. On the other hand, in the charging process, we use a battery as the electrical energy supply, so the non-spontaneous reaction can occur, and the products can be converted into the reactants again. So we have some examples on secondary cells. Our first example is about the nickel-cadmium battery. The active components of a rechargeable nickel-cadmium battery are nickel hydroxide at the cathode and cadmium at the anode. For the electrolyte, usually potassium hydroxide is used. Due to their low internal resistance and very good current conducting properties, nickel-cadmium cell can supply extremely high currents and can be recharged rapidly. At the anode, cadmium loses 2 electrons and combine with hydroxide ions to form cadmium hydroxide plus 2 electrons. At the cathode, hydrated nickel oxide is reduced and reacts with water to form nickel hydroxide and hydroxide ions. We are moving into our second example, which is lead storage battery. The battery is composed of 6 cells in series to give an overall 12 volts supply. In the discharged state, both the positive and the negative plates become lead-2 sulfate. The electrolyte loses much of its dissolved sulfuric acid and becomes primarily water. So the reactions of the cell are as follows. At the anode, lead loses 2 electrons and reacts with hydrogen sulfate to give lead sulfate and 2 electrons. At the cathode, lead-4 oxide gains 2 electrons and reacts with hydrogen sulfate to give lead sulfate and water. Combining these 2 reactions, so we get the overall reaction as follows. So let's move on to the charge chemistry of the battery. In the charged state, we use an outside source EMF so the non-spontaneous reaction can proceed. Unlike the discharging process, the anode and the cathode signs will be reversed, so the anode will have a plus sign and the cathode will have a negative sign. At the cathode, electrons are being pushed into the cathode from the EMF source. The cathode here has negative sign. Lead sulfate gains 2 electrons and is reduced into lead again. At the anode, electrons are being pulled out of the anode by the EMF source. The anode here has a positive sign. Here lead sulfate loses 2 electrons and reacts with water to give lead-4 oxide. In the end, don't get confused. The anode is the electrode at which oxidation reaction occurs, and the cathode is the electrode at which reduction reaction happens. That's a general rule.
Welcome back from that lesson. I trust you learned a lot. Some of the things you have learned is that electrochemical cells, which are also called voltaic or galvanic cells, can be used to generate electricity when you have 2 electrolytes in 2 different half cells undergoing redox equation that generates electric current that to generate power. You can also find out that these cells are connected together by your salt bridge.